Okay, welcome to video class 36, and we are continuing our discussion on Nyquist stability criterion. Now, in the first video or in the first part of this, we have discussed the theory, and in the last video, that's in video class 35, we have done some one problem, right? And this was the problem which we did. Uh, that is, the open loop transfer function is given k by s into s plus 2, and this s denotes that this is a type 1 system. So we know this step-by-step procedure. So first of all, you need to identify the Nyquist contour of the S-plane, which is to be mapped, and that is to be mapped in a g of j omega, h of j omega plane. So we'll get a Nyquist diagram. So first of all, the Nyquist contour you need to identify in the S-plane. Okay, and when you identify that, since it is a type 1 system, that means there is a pole residing at the origin, and that you need to exclude. So wherever if you find a pole in the on the imaginary axis, you need to exclude that. So this is a case where that lies at the origin itself. Now we will be doing a problem where some of the poles resides on the imaginary axis. Still the real part is 0. So in that case, how this is going to be, that all we will study. So for the meantime, we'll start with another simple problem where you don't have any pole at the origin, right? Here in this case, since it is a type 1 system, you have that has to be excluded. So you will be having S-plane like this. You need to exclude this, so that this Nyquist contour, in order to map this, you need to divide this into, or you need to segmentize this. So you've got four segments. One is the AB line segment, then you have a BC circular segment, then you have a CD, which is a line segment again, and a DA, which is again a small circular segment. Okay, so now let's move on to another problem where you are asked to examine the closed loop stability of a system whose open loop transfer function is given by GSHS is equal to 50 by s plus 1 into s plus 2. The first step is, so always the step 1 is you need to identify the open loop poles, or the so in this poles and zeros. So here you can see that you have zeros as poles as s1 is equal to, or call it as p1 is equal to -1, p2 is equal to -2, and we have seen this, none of these poles are right half poles, right? These are all left half poles. So what can you say about the p plus? So the p plus, or the poles at the right half of the S plane, is 0. Okay, right? So this is it. So this is the information that you got from this given open loop transfer function, and that is the first step. Okay, now coming to the second step, coming to the step 2. In step 2, what you need to find out is, step 2, you need to identify the Nyquist contour, or the contour that you need to, in the S-plane, that you need to map in G of j omega, h of j omega. For that, the first thing that you need to identify is the type of the system. What is the type of the system? Because there is no S term over here, or it is actually s raised to 0, this is a type 0 system. That means type 0 system signifies that there is no pole at the origin. So what is your S-plane? The S-plane that is to be mapped is like this, right? So this is S is, say, sigma plus j omega. So that means the whole of the right half has to be mapped. Okay, so this is the plane, or the AS contour that you need to map. So this is, I'm drawing this as a dotted lines signifying that this radius r is r tending to infinity. And you don't have to exclude this point because there is no pole residing at the origin. So now you can name this segment as O, A and B, right? So that means you will be having how many segments? One is an OA segment, line segment, okay, starting from, so this can be considered as 0 to infinity plus. This is the point where, this is the point corresponding to j infinity plus. Then you have another, then you have, so this is the, and you need to show the direction. So OA is the first line segment, then you have an AB circular segment, right? Circular segment with radius tending to infinity, right? So this is a big circle. And then you have a BO, right? BO is again a line segment starting from, what is this point? This is actually j infinity minus, starting from j infinity minus to 0, right? So these are the three segments that are to be mapped into this plane, okay? So into the plane means, so you need to substitute g of j omega, h of j omega. So you need to have the mapping function. So anyway, so this is the point. So look at the difference between the previous problem. In the previous problem, you had 4 segments, 2 line segments and 2 circular segments, while you have only 3 segments. And note that the circular segment is having the direction. The direction is also important, or you may represent that circle as r e raised to minus j theta. Why minus? Because this is in the anti-clockwise direction. So this is the circle as limit r tends to infinity. So you have identified the contour. Now the next step is to map this to g of j omega, h of j omega, or the step 3 starts with the identifying the, or obtaining the mapping function, right? Mapping function f of j omega, or right, if you call this as f of s, let us call this as f of s, obtaining the f of mapping function f of j omega, and map the s contour onto this function. Okay, that's the next step. Okay, so for obtaining the mapping, what you need to do is you need to convert this s contour or the Nyquist contour into the function g of s h of s at s is equal to j omega, right? So this so you will be getting what? You will be getting a Nyquist contour, or that is that's called as the Nyquist diagram or the Nyquist plot. So this results in something called as a Nyquist diagram. This can be diagram, or you may note this name also, Nyquist plot. So sometimes you may be asked to obtain the Nyquist plot. So this is it. So how to get this function? This mapping function is obtained by putting, so again rewriting this g of s h of s as equal to 50 divided by s plus 1 into s plus 2, right? So putting s is equal to j omega, you will get this as 50 divided by j omega plus 1 into j omega plus 2, right? Now what is the next step? So now the next thing is you need to convert this f of omega. So this is g of j omega, h of j omega, or I'm calling this as f of omega. Now this you need to convert it into the form of m angle phi, or magnitude angle phi. Converting that, so how will you convert? So you can represent each term by its magnitude and angle. So when you do that, so this your f of j omega in its magnitude form will be, this will be 50 angle 0, right? So this is 50 angle 0 divided by what's the magnitude of this? This is root of 1 plus omega square. So root of 1 plus omega square, angle tan inverse omega, right? Tan inverse omega. Okay, then the other one will be root of, the other magnitude will be root of 2 square plus omega square. So that will be 4 plus omega square. Tan inverse, what's that? Tan inverse omega by 2, right? Tan inverse omega by 2. So this is it. So how will you evaluate that? That's the next thing. Now, okay, so that this can be written as, okay, 50 by, what are the magnitudes? You can bring the magnitudes on one group together as root of 1 plus omega square. This is a magnitude, into 4 plus omega square, into, what is this? This will be 0 minus of, right? You need to, so this is angle, the numerator angle minus the denominator angle. So this becomes angle minus tan inverse omega minus tan inverse omega by 2, right? So this is the magnitude angle form of f of j omega. So that's the next step. After obtaining the g of j omega, h of j omega, convert this into magnitude angle form. And this is what is required to obtain the mapping of this f of j omega. So now the next step is, now in this next step is to plot this map this segments to this j omega axis, right? So that means I want to obtain this, convert this into this plane. So this is f of real of f of omega, j omega, and imaginary of f of j omega. That's what I'm going to plot for different frequencies. Now I need to plot the first segment that I need to plot is the OA. So plotting OA means I want to plot 2 points, that is at omega is equal to, plot 2 points, omega is equal to 0 and omega is equal to infinity plus, right? So this is infinity plus, this is j infinity plus. Okay, now doing that, we'll get this as, so at omega is equal to 0, let us see what is the magnitude. Once when you put omega is equal to 0, you will get this value as 25, right? Right? This value is 50 divided by root of 1 plus, this is 0, 50 divided by, this is 2 square, right? 50 divided by 2, right? 50 divided by 2, that is equal to 25. Angle, what about omega is equal to 0, minus tan inverse 0 is 0, this is also 0. So this is minus 0, so this will be 25 angle minus 0. You should not ignore this negative sign. Since it is 0, there is a tendency always to ignore this. There is nothing like minus 0 and plus 0. But here you need to consider this, because a negative number plus another negative number has to be negative. That's the concept. So you need to preserve this negative. That's very important. Okay. Otherwise you may be ending up in a different picture. Okay. So it's very important. Now what happens at omega is equal to infinity plus? Now when you need to substitute in this way. So comparing this omega square and the omega square, what you get is, with this 1 and 4, the 1 and 4 becomes negligible at omega is equal to infinity. So this becomes root of omega square into root of omega square, right? So that is omega square. 50 by, so at omega is equal to infinity, the magnitude you are going to get is omega 50 by omega square. Now when you substitute this omega square as infinity, okay, so you will be getting this as 0, right? So this will be 0. What about tan inverse infinity? Now tan inverse infinity is again infinity. Tan inverse infinity by 2, it's again infinity, right? So this is minus 90, angle minus 180, right? So this is angle minus 180 degree. So this is how you got, right? 25 angle minus 0, 0 angle minus 180. So these are the 2 points that we got when we have mapped these 2 points in this f of s plane, right? So let us identify that point. Look at this. You have a magnitude 25. Now the question is, this is magnitude. Now where will you plot this 25? Okay, will it be this point or this point? This is just the magnitude, so that can be negative 25 as well as plus 25. Okay, so this is, so for that you need this information. If you are not putting this negative 0, you'll be getting a different picture. Okay, so this angle shows you which is the point. So angle always is measured from this axis, right? From this axis. So anti-clockwise is taken as positive. So this will be, if the angle is in this direction, or if you take in this direction, then this is always a positive angle, while if you move in this direction, it is 0. So it shows that 25 angle minus 0 means this has to lie over here, right? Right? If it would have been somewhere over here, it has to be minus 180 degree, right? This is minus 1. With respect to this axis, this positive real axis, this is actually minus 180. So if the point should be at, if the 25 has to be marked over here, this angle should have been minus 180 degree, right? So this is at 0 degree, that means this is the point. Now what is the next point? Next point is 0. So you know that this is the point 0. Now we have a, I mean, there is a, what are the possible ways by which this particular, so this is in between, you have omegas ranging from 0 to infinity. That means you are varying omega. So as you vary, this plot has to travel. So then now the next question is, where, in which direction will it travel? Will it travel through these positive quadrants, or will it travel through this negative quadrant? There. So for this you need to be a bit careful. Otherwise, see, you may be, there is a chance always to draw like this, right? Okay. Okay. So there is a tendency to plot like this, right? And come to this origin. Okay, one can think of like this. No, it's not possible. Why? Because the angle says that this is 0 anyway, but this is at minus 180. So if the point is in this way, this has to be, okay, this has to be plus 180. So if it reaches, definitely it will be reaching at this point, but which direction? So if it moves in this direction only, then the angle will be minus 180 degree, right? Okay, so had it been in this way, the angle has to be plus 180. So this is minus 180, that means this is the point at which it comes over here. Now what is the speciality of this segment, BO segment? BO is just the mirror image of OA. That means if this is actually omega is equal to 0 point, and this corresponds to omega is equal to infinity plus. Now what must be this BO point, or okay, so the BO has to be like this, right? Look at this, this is infinity. Now the next point is infinity minus, so that means this has to be the upper, just upper point refers to infinity minus, and that has to travel exactly similar to this picture, the mirror image of that. So you will be getting a picture like this, right? Okay, right? Now so you got the, once you get OA, it is easy to get. So you will be getting BO, and that is nothing but it is the mirror image of OA. Okay, now what is the next point? Next point is next one is the segment. The third segment is which is the third segment. Third segment is this AB segment or the circular segment. Now let us see how that segment gets mapped into this. Okay, so you need to mark the points anyway. So this actually started from this, right? This, so you need to mark this as, this will be your direction, this is your direction, and it comes over here. Okay, now let us put the direction after plotting, after mapping this big circle. Okay, let's see how is it. Now how will you plot this big circle? So this is the big circle, r e raised to minus j theta. Okay, so the segment AB is nothing but it is r e raised to minus j theta as r tends to infinity, right? So r e raised to minus j theta, why it is called as r e raised to minus j theta? Because this is showing a clockwise direction. Okay, so this is a big circle. Now how to plot this? Now how to map is, you just substitute j of s. You need to take the open loop transfer function in the s domain and put s is equal to r e raised to minus j theta as limit r tends to infinity. Okay, so what is your g of s h of s? G of s h of s is 50 divided by s into s plus 2 at s is equal to r e raised to minus j theta as limit r tends to infinity. Okay, so that you will get this as 50 divided by, okay, r e raised to minus j theta plus 1 into r e raised to minus j theta plus 2. Okay, so everywhere you need to put limit r tends to infinity, limit r tends to infinity. This is all. Okay, we have done this previously as well. Now when you compare this radius to be, this is very infinite radius, so comparing this you can ignore this 1 and 2, so that this becomes 50 divided by r square limit r tends to infinity, r square, right, into e raised to minus 2j theta. 2 has no significance. The only thing is that we are worried only about the sign. So what's going to be this? This is 50 by r square. So when you put r is equal to infinity, this becomes 0 into e raised to plus 2j theta. That means, what is this? This is a small circle with the radius 0 and direction in the anti-clockwise direction. Okay, so what we have considered was, we have considered a clockwise circle, and how to plot that. So anyway, we know that a circle with radius 0 is anyway it's 0. So that should come between, and that is a point that come between minus j infinity and plus j infinity and minus j infinity. And in this plot we know that this is the point, right? This is the point that, so this just the point just below this is j infinity plus, the point just above this, the origin is j infinity minus. So this point, this circle has to come in between infinity plus and infinity minus, right? Anyway, that becomes a point. Now if you want to continue this direction, this particular circle, imagine that you have a small circle over here. So if this circle has to continue this direction, this circle has to be in the anti-clockwise direction, and that's what this sign suggests. Okay, so you don't have to you don't have to draw like this anyway. You don't have to draw like this. Consider that as a point. So that means it is just, the information is the big circle is mapped as a point. Okay, and how will you continue with this? So it is anti-clockwise, and then the direction will be like this, it will be like this. So this is a picture that you got. Okay, so that is your Nyquist diagram or Nyquist plot. Okay, now let us see the number of encirclements around the point minus 1 plus j0. So in this figure, minus 1 plus j0 comes over here, right? This is minus 1 plus j0, right? So this figure shows that this is in no way it's going to reach what? It's going to arrive at this. It's going to encircle this point -1. So what is your n? You got your n to be equal to 0, right? And what must be a step 5? Step 5 is to apply that. So the number of encirclements is equal to, okay, you're going to find out applying n is equal to p z plus, very important, z plus minus p plus. We have already found out the p plus as 0. So your p plus is 0 and the encirclement is 0. Okay, z plus minus 0. So what you're going to get is z plus is 0. Now the z plus, for that is what the Nyquist criterion says. For a system to be stable, the z plus, okay, has to be equal to 0. Okay, so what we did is we applied this principle of argument and then applied the criterion to arrive at the conclusion that the system is a stable system. Okay, system is a stable system. Okay, now let us see another simple system which is an unstable system.